Hello guys, we are back with another interview problem that is minimize scheduling headaches, clone yourself for overlapping events. Okay, so let's read the problem statement. So you have a calendar with n events. Each event is defined by start and end time. Okay, so we have an event and event has a start time and end time. Okay, some events may overlap, making it impossible for a single person to attend all of them. To ensure that each event is attended, you need to create K clones of yourself. Each clone can attend a subset of non overlapping events. The objective is to minimize the number of clones required to cover all the events. So we need to minimize the K. So let's look at the few examples to understand it better. So here we have events 1, 3. So 1 is the start time and 3 is the end time. From 2 to 5 and 4 to 6. Okay, so we have 1, 2, 3, 4, 5, 6. So first event starts at 1 and ends at 3. Second from 2 to 5, from 2 to 5, and third 4 to 6, from 4 to 6. Okay, so here we can see that 1 and 2 are overlapping, right? And 2 and 3 are overlapping. So if we create two clones, the first clone will attend the event from 1 to 3 and 4 to 6. Okay, because these two are not overlapping. So one clone can attend these two events, and another clone will attend event from 2 to 5. So 2 to 5. So our output would be 2. So let's look at the another example. So here we have 1 to 4, 2 to 3, 3 to 5, and 7 to 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So first event is 1 to 4, second is 2 to 3, then 3 to 5, and 7 to 9. Okay, so you can see that these are overlapping, these two are overlapping, and these two are not overlapping. This is not overlapping with any of the other events. So here also we need two clones. One clone will attend from 1 to 4 and 7 to 9. The second clone will attend 2 to 3 and 3 to 5, the third event, 3 to 5. So we need two clones. Okay, so let's solve this problem. So let's say these are the events A, B, C, D, E, F, G. Okay, so first thing what we'll do, we'll sort the events as per their start time so that we can process them in the chronological order. So first we'll sort 1, 5, then 2, 17, 3, 10, 3, 14, 8, 12, then 15 to 16, 15 to 16, and 16 to 18. Okay, so now we have sorted these events as per their start time. Now we'll process these events from left to right. Okay, so we'll take the first event 1, 5. Currently there are no clones, so we'll create a new clone. We call it as C1. So C1 will store the end time of the event which it is attending currently. So we'll assign this event to C1 and store the end time, which is 5, right? Now we will also maintain a min heap. Okay, so every time we create a new clone, we'll add it to the min heap. So min heap is used to keep track of the end time of the clones, always allowing access to the clones that finishes earliest. Okay, so we'll add it to the min heap. Now the second event is 217. So let's say this is a heap, and currently there is only one clone, and the clone finish time is 5, and this event start time is 2. So these two are overlapping. So what we'll do, we'll create another clone. We call it as C2, right? And we'll put the end time here, 17, right? Now let's process the third event, which is 310. Now this is the heap. So we check the heap. and compare it with the clone which finishes earliest. So here it is 5. So this starts at 3 and this clone finishes at 5. So again, there is a clash. So we create a new clone. We call it as C3 and the end time is 10, right? Now the next event is 314. So this starts at 3 and the clone which finishes earliest in this heap is again C1. Again, there is a clash. There is a start time, end time. So we create a new clone. We call it as C4 and the end time is 14, right? Now, the next event is 812. So this start time is 8 and in the heap, the clone which finishes earliest is C1. So this clone can attend this event. So what we'll do, this will be assigned to C1 and we'll update the end time of C1 to 12, this event end time. So now this is 12. Okay. Next event is 15, 16. It starts at 15, ends at 16. So now in this heap, the clone which finishes earliest is C3. And C3 can attend this event because C3 finishes at 10 and this event starts at 15. So C3 will take this event and will update the end time here, 16, right? And the last event is 16, which starts at 16 and ends at 18. So in this heap, C1 can take. C1 is the clone which finishes at 12 and can take this. So C1 will take this event and will update the end time as 18. Okay. So here we needed total 4 clones to attend all of these events. Okay. So let's go back to the problem. So this is a greedy solution. First, sorting the events. This sorts the event based on their start time, ensuring we process them in the chronological order. Heap initialization. The min heap is used to keep track of the end time of clones, always allowing access to the clone that finishes earliest. Why we are doing that? To reduce the time complexity. So here, let's say we have a 4 clones here and we have another event, let's say 15, 19, right? If you're not maintaining the heap here, we need to iterate through all the clones, right? To find out which clone can take this event, right? So this will increase the time complexity. So this is n, n events. And in the worst case, there'll be n clones if all are overlapping. So our time complexity would be n square if you are not maintaining the heap. But if you are maintaining the heap, we'll compare it only with the clone that finishes earliest, okay? So that will be done in O of 1 time. But maintaining the heap will take log n time. So the overall time complexity in that case would be n log n, right? So let's come back here, processing events. The for loop iterate over each event, determine if the earliest available clone, the one with the smallest end time, can attend the event. If the clone can attend, its end time is updated. If no clone can attend, a new clone is created and added to the heap. And at the end, count the number of clones. That is basically the size of the heap. Okay, so let's look at the code. Here we have function that takes all the events as input. We sort the events as per their start time. Here we have a priority queue, which is a heap, and heap is maintained as per the end time of the clones. So now we'll process all the events. So if the clone queue is empty, that means there are no clones. We create a new clone and add it to the heap. Else, we'll pick the clone which finishes earliest, compare the end time of the clone with the start time of the event. And if the end time is less than equal to start time, that means this clone can take this event. So we'll take the clone, update the end time, and again add it back to the queue. If this condition fails, that means no clone can attend. So we need to create a new clone. So we'll create a new clone and add it to the queue. And at the end, we'll take the size of the queue or heap, and that will be the minimum number of clones required to cover these events. Okay, so let's run this code. So this is the same example. 1, 5, 3, 14, 3, 10, 8, 12, 2, 17, 16, 18, and 15, 16. So let's run this. And minimum number of clues required to cover all events are 4. 1, 2, 3, 4. So this is how we will solve this problem. Now we can mark this problem as completed. And we'll see you guys in the next video with a new problem. Bye bye.